page 91. And on this one, let's round to hundredths. I'm just making up the rounding rule so that we all get the same answer. On your final exam, remember to read closely for the rounding rule. A ramp makes an angle of 5 degrees with the ground. If the ramp is 8 meters long, how high does the ramp rise from the ground? So we want to know this rise right here. Again, this picture is not to scale. The hypotenuse is the ramp, that's 8. The rise is what we want to know, and we know little theta is 5 degrees. So we want hypotenuse and opposite, that's the sine ratio. So the sine of 5 equals opposite, that's the rise, over hypotenuse, that's 8. These are relatively small numbers, so I would not expect a huge answer. We're going to get the rise to be about 8 times the sine of 5. And it's actually less than a meter, which makes sense. If that's a wheelchair ramp, it's not going to be very steep. I would not expect something too steep or the chair would not roll up the slope. Okay, a wheelchair ramp is designed with an angle of 12 degrees to the ground or to the horizontal. We don't know that that's the ground. It could be on a stage. It could be anywhere. So we'll call it the horizontal. If the ramp is 4 meters long, how high will the ramp rise? So it's similar to the question before. We're looking for the rise, which is the opposite. And we know the hypotenuse, which is 4 meters. And 12 degrees is theta. So we want O and H, that is sine. I don't want you to think that every wheelchair problem is a sine ratio. We cannot make that call. You have to read the question and really understand what you're looking for. So rise, and then 4 is hypotenuse. So 4, and you do it to both sides. It's one of your algebra golden rules. So 4 times the sine of 12. Again, I wouldn't expect anything huge because we're talking about a wheelchair ramp. And again, that's less than a full meter. Excuse me. The pollen's getting to me today. A sailor is on a boat 30 meters away from the base of a lighthouse. So here's a lighthouse. That's all one word, but I don't have room. So the light is up here. And down here's the base of the lighthouse, and it tells us that the boat is out here 30 meters away. The angle of elevation to the top of the lighthouse from the boat is 18 degrees. So how tall is the lighthouse? Sorry, I didn't mean to do that. I've already put 18 in there. So theta is 18 degrees. We know adjacent is 30. And we want to know opposite. We want to know how tall the lighthouse is. So this is O and A. That's going to be TOA. So tangent of 18 is O. I'm going to use L there for lighthouse. Over adjacent. Multiply by 30. Do it to both sides. So the lighthouse is going to be approximately 30 times the tangent of 18. And that's about 9.75 meters. It's a pretty small lighthouse, but that's reasonable, especially given the story that we have here. So the lighthouse is almost 10 meters tall. A satellite dish is positioned at an angle of 35 degrees to the ground. So we've got this dish that's making a 35-degree angle to the ground. If the dish is 4 meters above the ground, that's an altitude, so that's a straight perpendicular distance. That's 4 meters. What is the distance between the top of the dish and the point where the signal is received? So we're looking for this distance. We're looking for hypotenuse. So that's going to be the distance. The opposite is 4 and theta is 35. So we're looking at sine. Sine of 35 is going to be opposite over hypotenuse. So let's multiply both sides by d, and that will allow me to cancel it here. And then we have to divide out sine 35 to get it away from the d. So d is going to be approximately about almost 7, but we're rounding to hundredths on this one. So 6.97 meters for that distance.